So let us see. So what is this question? F of x is 1 if x is rational, 0 if x is irrational. Then f has discontinuities of second kind, discontinuities of first kind. F of x plus means RHL, x minus means LHL exist. So that means if RHL exists for all x, here in place of x no value given. If it is 0 plus means right hand limit at 0. 1 plus means right hand limit at 1. But here nothing given. That means x plus means right RHL exists for every x belonging to R. X minus means LHL. LHL exists for all x belonging to R. These are the options. So as I said yesterday, how to work out such questions? To work out such questions, generally we go for yes. So what we do in order to find out that, in order to find out such questions, we calculate not left hand limit, right hand limit. We divide them into cases. What are the cases? We divide them into case 1, x belonging to Q, x belonging to R minus Q. Like that we divide. Is it not? So let us calculate for them. X belongs to R. Then what is the right hand? We want to find. Let us. We cannot call a right hand limit left hand limit. Simply we call it case 1 and case 2. Okay. Let us this question here. This model we have done. So I will find out case 1. Case 1 means x belonging to Q. A is fixed point. A is fixed. That is the A belongs to R. It may be rational, it may be irrational, anything. As I said, this is A. Your x is belonging to Q. So x is here, A is here. So x belongs to Q limit means x is approaching A, x is a rational number. Through set of rationals, it is approaching x. Between x and A, there will be rationals, there will be irrationals. Rationals are like this. Irrationals, let us denote by stars. As I said yesterday, x can approach A through rational numbers, jumping over rationals. It can approach through irrational. These are the two cases. Irrespective of the approach, limit should be finite and unique. When you look at this, we want to find out limit x approaching A f of x. This is nothing but limit x approaching A. F of x is nothing but when x belongs to Q, x is rational, f of x is 1. Replace x by A, there is no x, so 1. What is case 2? X belongs to R minus. In this case, we want to, through steps of irrationals, x is approaching. Then we want to find out limit x approaching A, f of x. This will be limit x approaching A when x is irrational, value is 0. So 1 cannot be equal to 0. Therefore, limit is not unique. Limit should be unique irrespective of the approach. Through rationals, if you approach, it is 1. Irrationals, if you approach, it is 0. So limit is not unique. Hence, f has discontinuity. Which type? LHL exists, RHL exists. Finite. Jump discontinuity or first kind. This is at what point? At every point. Because whatever may be your A belongs to R. That means A may be rational, A may be irrational. Whatever may be your A. For what values of A it is discontinuous means for all A it is discontinuous only. Therefore, we say that f has discontinuity of the first kind at every point. Only one option correct. So this is the right option. So this is how we can work out questions. That's what we have seen. Now let us see third question. This question, when you look at it, you can see, suppose A and C are real numbers. This model, very important. We'll copy here, place will not be sufficient. So we will do this. Very interesting question, repeated in many papers. So when you look at this question, suppose A and C are real numbers, C is positive, F is defined on this interval. It is not Fnx actually, F, not Fnx, Fx. There is no N at all. So this is Fx. N naught. So Fx is x power A sin x power minus C, x naught 0, 0 if x is 0. Then which of the one of the following statements is true? Is it continuous? F dash 0 exists like this. Let us see which one of the following is true. Is true means only one true. Let us check for continuity. So for what values of A it is continuous, we have to find. F of x is x power A sin x power minus C. So this is bounded. Whatever may be C value, this is x power A sin 1 by x power. C is 0, you have to divide into cases. C is any real number. C may be positive. If it is positive, 1 by x square, 1 by x cube like that. If C is negative, x power minus 1. So this will go to numerator, sin x square like that. C is 0, x power 0 is 1, sin 1, which is constant. So constant functions always bounded. So this is always bounded. Sin theta is always bounded. That is, modulus of sin theta is always less than or equal to 1. So we know limit, when is it continuous? Limit x approaching 0 f of x. For f to be continuous, limit x approaching 0 f of x must be f of 0. What is f of 0? At x equal to 0, f of 0 is 0. So for what values of A, this will be 0. So limit x approaching 0, f of x will be limit x approaching 0, x power A sin 1 by x power C. We have seen whatever may be C value, this is always bounded function. Modulus of sin theta less than or equal to 1. Whatever may be theta, negative, positive, constant, anything. This will be 0 if and only if A is positive. If A is negative, it will become 1 by x square, it will become infinity. Yesterday we have seen this limit exists. One of them is the limit is 0, the other is bounded, then only limit is 0, provided A is positive. Therefore, f is continuous. Why we want it to be 0? Because f of 0 is 0. This limit must be equal to 0. When is it going to be 0? Only when this is 0. When is this going to be 0? Only when A is positive. Because if A is 0, x power 0 becomes 1. It is not 0. If A is negative, it will become 1 by x square, 1 by x cube. So 1 by 0 square, 1 by 0 cube, which is infinity, not 0. So for this to be 0, this has to be positive. Therefore, f is continuous. Continuous means limit equal to f of 0 if and only if A is positive. The remaining we need not check because which of the following statement is true. Had it been R true, we would have verified. But no, waste of time. So this is the. Okay. Any doubt in this? Some students, what they will do? They will divide this by 1 by x power C, limit theta going to 0. But here, this is not 0. The 1 by 0 becomes infinity. It is not sin theta by theta. Not only sin theta by theta, theta should go to 0. Then only you can write standard limit. Limit theta going to 0, sin theta by theta 1. That you can write only when theta goes to 0. But here x goes to 0, 1 by 0 becomes infinity. So you cannot apply such standard results. We need to, this is always bounded, whether C positive, C negative, C 0, always bounded. Therefore, this only should be 0. 0 into bounded function is 0. This happens only when A is positive. So this is the right option. This is given in one of the papers. Next. Yes, differentiability we haven't completed. This will do. Second one after I discuss differentiability. Here, f is continuous but not differentiable. So this also 13th question also I will do after giving concept of differential. Okay, no? So this also I have solved. Okay, fine. Let us enter into our today's topic. So we have completed continuity, types of discontinuities. I would like to discuss one more question if you are interested. This is how many ever I do. Again, the question which will be given to you will be u f of x equal to 2 into mod x by 3x minus mod x. Discuss continuity at x equal to minus 1 by 2. X discuss continuity. Is it continuous at x equal to minus 1 by 2 at x equal to 1? If it is only mod x, we know at 1 it is discontinuous. At minus 1 by 2 it is continuous. If it is box x is continuous at every non-integer, discontinuous at every integer. It is having jump discontinuous. Right? We are asked to find out here for this. So let us see how to find it. So let us go for LHL and RHL. So case 1, first one, at x equal to minus 1. Whenever box x comes, we have to go for LH concept. So we have to calculate limit, this is LHL, we have to find. This is limit, h approaching 0, x less than minus 1. This is our A. Less than A means A minus h. A minus h. So minus 1 by 2 minus h of fx. So replace wherever x is there by 1 by 2 minus 1 by 2 minus h. Box minus 1 by 2 minus h divided by 3 into minus 1 by 2 minus h minus box minus 1 by 2 minus h. So first to simplify, then apply. So if you simplify this, I have one doubt. Can we do it directly? Because we can have limit, algebra of limits we can apply, and then we can calculate is my field. Let us do it. If it exists, we can apply directly. At minus 1 by 2 limit exists. At minus 1 by 2 limit exists. So how to find out limit? Because when do we say it is continuous? Limit x approaching a fx should be f of k. When you know limit exists, you need not go for LHL RHL concept. Here we already know box x limit exists at minus 1 by 2. So at minus 1 by 2, we need not go for LHL RHL. Directly we can evaluate. So at box x, we have to, because we know limit does not exist. So this will be waste of time. So let us go for now limit x approaching minus 1 by 2 of fx. This is minus 1 by 2 of 2 box x by 3x minus box x, is it? Yeah, box. So let us evaluate that. You know algebra of limits. This is 2 limit x approaching minus 1 by 2 box x divided by 3 into limit x approaching minus 1 by 2x minus limit x approaching minus 1 by 2 box x. We know box x limit exists at every integer, non-integer. This is not an integer. So limit exists. If it exists, we can directly replace. If it exists. If it doesn't exist, we cannot. Okay. This is limit x approaching. This is minus box minus 1 by 2. Calculate the box value. How to calculate this box value? Minus 0.5. Yesterday we have seen this is minus 3 by 2 minus box minus 0.5. Whenever it is negative, box means this integer part minus 1, minus 1, a minus 1. So 0 minus 1, 3 by 2, minus 0 minus. So this is minus 2 minus 1.5 minus into minus plus. So minus 2 divided by minus 0.5. This is minus by minus plus 20 by 5, which is 4. So minus 1 by 2 formula. What is box? Takes only integer part, 0. And it is negative. Negative means a minus 1. If it is positive, take only integer part. If it is negative, take integer part minus 1. Here also, integer part minus 1. So minus into minus becomes plus. Minus 3 plus 1 is minus 1 by 2. This becomes 4. This limit exists. And f of x is equal to limit of this is equal to 4. Now, when is it continuous? Provided it is equal to f of minus 1. How to find out? 2 into minus 1 by 2. Replace wherever x is there by minus 1. We'll get the same answer. Because this is what we got it here. We get same answer. Directly replace x by this. So therefore, it is continuous. These two are equal. Limit exists, and limit x approaching minus 1 by 2, f of x is equal to f of minus 1. Therefore, f is continuous at x equal to minus 1. Because limit exists. If limit does not exist, we don't know. We have to calculate. So at x is equal to 1, particularly, we want to calculate 1 only. I think hope long 1 only. LHL we have to calculate. Because at integer, we don't know whether limit exists or not. For box x, it does not exist, but it is box x by box x is there. Sometimes negative becomes positive. So yesterday we have seen a box x minus box minus x is limit exists. Only for box x, it does not exist. So if it is only box x, we would have concluded. But apart from that, we are having something else there. So you need to check. So limit h approaching 0, x less than 1. Less than 1 means 1 minus h of 2 box x by 3x minus box x. So replace wherever x is there by 1 minus h. H approaching 0, 2 into box 1 minus h divided by 3 into 1 minus h minus box 1 minus h. We have to calculate box 1 minus h value. This is 1. This is 1 minus h. 1 minus h is less than 1. 1 plus h will be greater than 1. So this is 0 and so on. So this is 1 minus h less than 1 minus h. This is 1 minus h less than 1 minus h. Integers are this. Immediate integer is 0, left side. As sir said, immediate left is 0. So this is limit h approaching 0, 2 into 0 divided by 3 into 1 minus h. This is as it is. This is box. Box we have to calculate. This is 0. So 2 into 0 is 0. 0 by replace h by 0. So 3, 1 minus 0 is 1. 3 ones are 3. Which is 0. So LHL is 0. You have to calculate RHL. What is RHL? RHL is nothing but limit h approaching 0, 1 plus h. 1 plus h. X equal to 1 plus h of 2 into box x by 3x minus box. This is nothing but limit h approaching 0, replace x by 1 plus h. 3 into 1 plus h. 1 plus h. Now, replace, first simplify. Less bodies box means greatest integer less than 1 plus h. Less than 1 plus h, what is the greatest integer? Greatest means immediate preceding. Immediate preceding to 1 plus h, what is the integer is 1. Because 1 is here, this is a 1. This is 1. This is 1 minus h, 0 and so on. This is 1 minus h. This is 1. 1 plus h. Less than 1 plus h, immediate integer is 1. Because less than this, what are all the integers? 1, 0, minus 1 and so on. Greatest is immediate preceding. So it is 1. So limit h approaching 0, 2 into 1 divided by 3 into 1 plus h minus 1. So replace h by 0 now, 2 by 3 minus 1, 2 by 2, which is 1. So RHL is 1, LHL is 0. So LHL is not equal to RHL. Therefore, F has jump discontinuity. Jump discontinuity at 1. So at x equal to 1. You may say, madam, we can conclude directly from here itself because box x is discontinuous at 1. Sometimes it may be depending on the question. Therefore, better you do it. Sometimes you will not be asked to test whether it is continuous or not. You'll be asked to find for this function what is f of 1 minus. Like in the previous question, they asked 1 plus. Then you should know how to do it. 1 minus means left hand limit. 1 plus means right. At 1 we are doing. 1 plus means right hand limit at 1. F minus means left hand limit. This we got it as 0. This we got it as. Sometimes will be asked to evaluate separately. Then you should know how to do it. Therefore, I have shown the procedure. Okay. This is how you can work out number of questions based on this. So let us go for now. We have one more shortcut. You like these shortcuts very much. So I would like to give you that shortcut. You can note down somewhere and try to memorize them. In the examination, we cannot work out. So you can have this important result. Every monotonic function given in one of the papers, every monotonic function defined on an interval I, has only jump discontinuity. Has only jump discontinuity. It cannot have discontinuity of second kind or something like that. Whatever may be the interval. If it is monotonic function, every monotonic function defined on the interval will have only jump discontinuity. It cannot have other discontinuities. Very important result. And this, what is monotonic function? Already sir has discussed the monotonic sequence. So if x1 is less than x2, implies fx1 is less than fx2, less than or equal to fx2. And whenever x1 is greater than x2, if fx1 is greater than or equal to x2, for all x1, x2 in I, then f is monotonic, increasing. F is increasing, monotonically increasing. We see. That means x1, x2, fx1, fx2, they should go in the same direction. If this is less, this also should be less or equal, worst case. If this is greater, this also should be greater. That is x1, x2 and fx1, fx2. If they move in the same direction, then it is increasing. If they go in the opposite direction, then it is decreasing. So if x1 is greater than x2 implies x1 is less than x2 implies fx1 is greater than or equal to fx2. And x1 is greater than x2 implies fx1 is less than or equal to fx2 for all x1, x2. Then we say this function is monotonically decreasing. Then f is decreasing. Monotonically decreasing. So because they are going in the opposite direction, earlier same direction. So if they go in the same direction, increasing, the opposite direction is greater, we are getting less. If it is less, we are getting greater. Then it is decreasing. If it is increasing or decreasing, then it is said to be f is either increasing or decreasing. Then it is said to be again or decreasing. Please mute. Decreasing, either increasing or decreasing. Then f is monotonic. Okay, this is original dimension. So if it is a monotonic function, if it will have what type of discontinuity? Only jump discontinuity. That is discontinuity of first kind. That means LHL is not equal to RHL. It will not have removable discontinuity. It will not have infinite discontinuity. It will not have second discontinuity of second kind. It will have only jump discontinuity given in one of the papers. Theoretical question. If it is monotonic function, then option A, it will have only jump discontinuity, only removable, only second kind. Like that, options were given. So important is it will have only jump discontinuity. This is one of the interesting results. So let us go for now. Next, another interesting result. Let us go for this. So second one. What is another interesting result is, try to memorize these results. The set of discontinuities, that is the points at which the function is discontinuities of monotonic function is countable. These are all theorems, but nobody will ask you to prove, but you need to remember this. This is also given. The set of, what can you say about the set of discontinuities of monotonic function is countable, uncountable, like that it will be given. So very important is monotonic function will have only discontinuity of first kind or jump discontinuity, and the points at which it is discontinued, all those points is always countable. Next. Another interesting result. Yesterday we have seen applications of intermediate value theorem, and all those we have completed. Now let us go for uniform continuity concept. So the difference between continuity and the uniform continuity. What is continuity is, again we have epsilon delta definition. So what is continuity according to epsilon delta definition? According to epsilon in delta definition, continuity means f is said to be continuous. F is said to be continuous at x equal to a if and only limit x approaching a, all definitions will be if and only if only is equal to f. This is like L is equal to f. Already we have seen this limit of the function, epsilon delta definition for limit of the function. How did we define? Whenever x minus a is less than delta, if fx minus L is less than epsilon, we say f is limit of f exists. And if that limit is equal to f of a, we say that it is continuous. So that is epsilon delta definition. Given epsilon greater than 0, there should exist a delta. This delta can depend on epsilon. It can depend on a also, the point. In case of continuity, delta, which is a function of epsilon and a. It may be only epsilon, or it may contain a also. What is a? The point at which you are testing, some constant. The point at which you are testing, delta epsilon comma a, such that only epsilon. Delta is function of, that is delta equal to epsilon by 2, delta equal to epsilon by 3. That's what is the meaning of delta function of epsilon. That means delta is in terms of epsilon. What is the meaning of this? Delta, you may get it as epsilon by 2a or epsilon a by 2, like that. It is in terms of a. Then we say delta depends on epsilon as well as on b. If we get delta is equal to epsilon by 2, epsilon by 3, we say it depends only on epsilon. So given epsilon greater than 0, there exists delta such that x minus fx minus f of a is less than epsilon whenever x minus a is less than. If this happens, we say function is continuous. Instead of L, we are having f of k. That is the only difference. That means you have to solve these two inequalities. get your delta. Delta can depend only on epsilon, it may depend on epsilon and A, but somehow you have to get a delta. Then we say F is continuous. For example, if limit x approaching fx approaching A, cos x equal to cos, that is cos is continuous, then delta is. You may get a question like this. That is if or you may get if cos x is continuous at x equal to, then delta is. You are given this question, for example. So how to find out delta using this definition is, what you have to do? We have to find delta such that, what is the condition? X minus fx minus f of t should be less than epsilon whenever x minus a is less than. We have to solve these two inequalities. So we have to solve this. So consider fx minus f of. What is this equal to? Cos x minus cos. This is in the form cos c minus cos minus 2 sin c plus d by 2 sin c minus d by. You know, my modulus of this will be modulus minus 2 sin x plus a by 2 into sin x minus a by 2. Modulus of minus 2 is 2. Now, sin theta has got two values. If it is small, inside angle is small, 2 are there for sin. Mod sin theta less than or equal to 1 for all theta. If theta is small, then sin theta is equal to theta. So when you look at it, x minus a by 2 is small. How do you know? X minus a is less than delta. Delta is small. This is still smaller than delta. So x minus a is small means x minus a by 2 is still small. So this is small. Whenever theta is small, sin theta is theta itself. So this is not small. X plus a by 2 is not small. Therefore, modulus of sin theta less than or equal to 1. So even though both are sin, for this we apply this formula. For this we apply this formula, because here theta is small, here theta is not small. If it is not small, 1. If it is small, then use theta. Modulus x minus a by 2, which is mod x minus. So we want fx minus f of a to be less than epsilon. So we got it to be less than or equal to mod x. We want this to be less than epsilon. When is it this less than epsilon? Only when this is less than epsilon. So this implies mod fx minus mod, this is f of a, is less than epsilon whenever x minus a is less than. Now compare this with the given equation. So this is less than epsilon whenever this is less than epsilon. When is left side less than epsilon? Only when right side is less than epsilon. So x minus a is less than epsilon we got. What is given is x minus a is less than delta. These two together means when are both going to be satisfied? Only when delta is less than or equal to epsilon. Because earlier we stated this and this will be satisfied only when delta is less than or equal. It should be positive, of course. Therefore, what are the values of delta? There are many values. In particular, delta can be epsilon. Delta can be anything, epsilon by 2, epsilon by 3, anything less than epsilon. So how many values are there for delta? Yes, infinitely. So all of them are depending only on epsilon, but not on a. You did not get your delta in terms of a. We got it independent. That is for all a. whatever may be your A value, delta is always equal to epsilon, epsilon by 2, epsilon by 3, and so on. That means delta doesn't depend on A. When do we say it depends on A? When you get delta in terms of A, if you get, then we say delta depends on epsilon as well as on A. But here delta we did not get in terms of A, we got it as constant in terms of epsilon. Therefore, delta does not, what is the value of delta means? Any one of them. Look at the option. Among the options, you may be given anything between 0 and epsilon. If epsilon is given, correct. Epsilon by 2 given, correct. Anything less than epsilon is correct answer. And it should be positive. So you cannot have minus epsilon by 2. It should be epsilon by 2, epsilon by 3, like that. How many delta? Infinitely. So this implies delta depends only on epsilon. Only on epsilon. But does not depend on A. Because you did not get delta in terms of A. If you get delta in terms of A, then we say A delta is depending on A. But it is depending only on epsilon, but does not depend on. This is what is called continuity. So this, if delta depends on only on epsilon, then we call the function not only as continuous, we call it as uniformly continuous at x, particularly over that interval. So when do we say function is uniformly continuous? Is if our delta value depends only on epsilon, it does not depend on the points A, then we call it as uniform continuity. If it depends on epsilon as well as on A, then we say it is continuous but not uniformly continuous. So what is the difference between continuity and uniform continuity? If delta depends only on A, difference. If delta depends only on epsilon, then F is uniformly continuous. On whatever may be the interval. So on I, we call it. That is for every A belonging to. If delta depends on epsilon as well as A, then F is continuous but not uniformly. This is the main difference between continuity and uniform continuity. For example, what is the original definition? I will write now. So what is uniform continuity? It is like continuity only, same definition, but it should not depend on points. It should depend only on epsilon. So if the function is continuous for all, whatever may be the values of A, or whatever may be the values of points, such continuity is what is called uniform continuity. The extended concept of continuity is uniform. Any disturbance from my side, ma? Any sound?
No, madam.
No, ma'am.
Okay. Uniform continuity. So if F is a function from S to R, then F is said to be uniformly continuous. I will give you original definition. I will show you how to escape doing like this, and by looking at that, how to identify whether it is uniformly continuous. First, I should give you concept, then shortcut, then application. This is how I am going. So F is said to be uniformly continuous, uniformly continuous on S. Always remember, uniform continuity is defined over a set or an interval. It is not defined at a point. Continuity is defined at a point. Uniform continuity is defined over an interval or a set. So uniformly continuous on, whereas continuity, it is defined at point, it is defined on interval also. Yesterday we have seen when is F is continuous on open interval, F is continuous on closed interval, when is it said to be continuous, that we have discussed. So continuity can be defined at a point, It can be defined over an interval also. But whereas uniform continuity is defined only over a set or an interval, it is not defined at a point. Uniform continuity అనేది ఒక పాయింట్ దగ్గర యూనిఫామ్లీ కంటిన్యూస్ ఎట్ ఎక్స్ ఈక్వల్ టు ఏ అనేది మీనింగ్లెస్. ఒక పాయింట్ దగ్గర ఎప్పుడు అది డిఫైన్ అవ్వదు. యూనిఫామ్ కంటిన్యూటీ కాన్సెప్ట్ ఈస్ ఓవర్ అన్ ఇంటర్వెల్. ఎఫ్ ఈస్ సెడ్ టు బి యూనిఫామ్లీ కంటిన్యూస్ ఓవర్ ఇంటర్వెల్ ఆర్ ఎఫ్ ఈస్ సెడ్ టు బి యూనిఫామ్లీ కంటిన్యూస్ ఓవర్ ఎస్. Uniformly continuous on yes if given epsilon greater than 0, there exists a delta which is depending only on epsilon such that modulus f of x1 minus f of x less than epsilon for all x1, x2 belonging to S. If this is satisfied, yes, for every pair of points, whatever may be x1 and x2, if your delta depends on epsilon, it does not depend on x1 and x2, we say it is uniformly continuous on S, because it should happen for every pair. Whenever you change the pair, you should get delta in terms of epsilon only. It should not depend on x1 and x2. Therefore, if delta is, you are not getting delta in terms of epsilon by x1 plus x2 or x1, x2 like that. If you get like this, it is not uniform continuous. It should be depending on only epsilon, that is epsilon by 2, epsilon by 3 like that. Okay. Now, let us go for now. What is the relation between continuity and uniform continuity? If a function is uniformly continuous, can we say it is continuous? If it is continuous, can we say it is uniformly continuous? If not, under what conditions? Let us see these points. So very important point is, if f is uniformly continuous on S, then f is continuous. So uniform continuity implies continuity. Continuity means you should have fx minus f of a less than epsilon. Fx minus f of a should be less than epsilon. So if it is uniformly continuous, automatically it will be continuous on S. On S means that is f is continuous at every point of S. For every A belonging to S. So how do we test this? F is uniformly continuous on S implies fx1 minus fx2 is less than epsilon whenever x1 minus x2 is less than. For all x1, x2 on this. This is original definition. Here I forgot to write. This such that this is less than epsilon whenever. What is the condition? Definition of uniform continuity? Whenever x1 and x2 is less than delta. That means whenever x1 is close to x2, fx1 is very close to fx2 because the difference is small. Whenever x1 is close to x2, if your fx1 is close to fx2, then we say function is uniformly continuous. So when it is true for all x1 and x2, if I give value also it should hold good. So in particular, if I give x1 equal to x, x2 equal to a, then what happens? Because it is continuous for all, in particular, when it is true for all, in particular, if you give a value also it should hold good. For x1 is equal to x, x2 is equal to a, belonging to S, we get fx minus f of a less than epsilon whenever x minus a is less than delta. If this is so, we say f is continuous. If this is satisfied, we know f is continuous at a belonging to S. Therefore, f is continuous on S at every x belonging. Therefore, f is continuous on S. Therefore, uniform continuity implies continuity. So, if a function is uniformly continuous, then automatically it is continuous. You need not check. Automatically it will be satisfied. But is the converse true? Answer is no. F is continuous on S does not imply f is uniformly continuous. If it is continuous, you cannot say f is uniformly continuous. Sometimes true, sometimes false. That is, f is continuous on S, then f need not be means sometimes true, sometimes false. Not necessarily. Need not be uniformly continuous. We'll see examples. But under what conditions? Under what conditions it will be uniformly continuous? If f is continuous on closed interval. If this S is closed interval, then definitely it is uniformly continuous. On closed interval. If it is open, you cannot say. But if it is closed, if it is open, sometimes uniformly continuous, sometimes not. But if it is continuous on closed interval, then definitely it is uniformly continuous. When do we say it is continuous on closed interval? Yesterday we have seen. If it is right continuous, that is right continuous at A, that is RHL equal to f of A, continuous at every point in between A and B, and it is RHL equal to f of A, and LHL equal to f of B, that is f is right continuous at A, left continuous at B, and continuous at every point in between, then we say it is uniformly continuous. So, for example, you are given f of x is equal to x square is question. Uniformly continuous on 1, 2. In fact, on any a, b. Suppose you are given this question. So, is f of x equal to x square uniformly continuous or not? We want to find. So, what is the concept? If it is continuous, actually we have to go to original definition, epsilon, delta, but this much time will not be there in the examination hall. Yours is MCQ. So, if you keep on doing like I did, x1 fx1 minus fx2 less than or not, then you will not be able to clear your entrance. So, there should be a shortcut. Then how do we check whether it is uniformly continuous on this interval or not? First, we have to check this is closed interval, luckily. If it is open interval, we cannot apply this result. Luckily, it is closed interval. If it is closed interval, we can escape doing some works. So, 1, 2, it is, that is x values are between 1 and 2. So, just now we have seen, if it is continuous on closed interval, then automatically it will be uniformly continuous. So, you can see fx equal to x square. Is it having any, is there any point where is it having a break anywhere? No break. No break at all. X square. What is the graph of this? Y equal to x square is the graph. The power of x is even. So, parabola. So, which axis divides? X power is even. So, y axis divides this into 2 equal. It is not having any break. It is smooth. Between 1 to 2. So, this is the origin. This is 1. This is 2. Between 1 to 2, it is smooth. No break at all. If there is no break, automatically it is continuous. Graphically. Even if you don't have graph, suppose we don't know how to draw graphs. Is it not well defined at any point? That we have to check. Is it becoming infinity or minus infinity at any point? No. X square is everywhere well defined. It will never become infinity and minus infinity at any point, any value in this interval. Therefore, this is always smooth, is continuous everywhere, not only on 1, 2, it is continuous everywhere. In particular, on this interval also continuous. On this interval also it is continuous. So, continuous on everywhere continuous means on this interval also continuous. Therefore, F is uniformly continuous. On the interval 1, 5. On every eta. Not only 1, 2 or any interval. This is how you can escape doing. Yeah. How about f of x equal to 1 by x? On the interval 0, 1. On the interval minus 1, on the interval 2, these are all 3 bits. Is it uniformly continuous? On this, on this, on this. So, how to check? First, we have to check whether it is continuous on the closed interval.
Yeah. Can I ask any question, Govardhan? 1 minute.
No, sir. No.
Yeah, okay. No.
So, is fx equal to 1 by x uniformly continuous on closed interval? 0, 1. Any one of you, can you answer? Is it continuous?
Not continuous at x equal to
0. So, fx equal to 1 by x is not defined, it is becoming infinity. At what point it is becoming infinity? When x is 0. So, at every other point it is well defined. So, there is no problem at any other point. So, at 0 only, 1 by 0 is becoming infinity. Function itself is not defined means it is not continuous. So, it is not continuous at 0. How about at all other points? It is smooth. There is no break at all. Therefore, it is well defined and smooth because there is no break point. So, it is going to be continuous at all points except at 0. So, fx equal to 1 by x is continuous everywhere except at x equal to f of x equal to, that is at x equal to 0. Therefore, f is not continuous on closed interval 0. So, it cannot be uniformly continuous. Not uniformly continuous.
Ma'am, ఇది ఓపెన్ ఇంటర్వల్ కూడా నాట్ కంటిన్యూ కదా మ్యామ్?
Continuous on open interval, but in order to apply shortcut, we have to test in this. Not continuous on this means there is a failure point. It is continuous only everywhere except at 0. So, not continuous on this means it is not continuous at any one of the points. If it fails at any one of the points, we say it is not continuous on closed interval. It does not mean it is not continuous on open interval. It is having failure at any one of the points in the closed interval. We say it is not continuous on that interval. Suppose there is a course or your part A, B, C is there. So, you have failed in part A. So, overall failure or not? Even though you have passed part 2, part 3, what is the overall result? Fail only. So if it fails in any one of the points in this interval, it is overall failure. So that does not mean you have not passed part 2, part 3. Passed part 2, part 3. But even then we say overall fail. Why? Because first part failed. Similarly here also. There is a failure point, at least one point at which it is not continuous. We say it is not continuous over the interval. It does not mean you have failed in all papers. Overall failure does not mean you failed in all papers. In at least one of the papers you have failed. So if there is at least one point at which it is not continuous, we say it is not continuous on 0, 1. It may be continuous at 1. It may be continuous in the open interval 0, 1. But it is not continuous at 0. One failure. So in the interval failure. If it is not continuous in the overall interval, then it is not uniformly continuous on 0. Okay. Next. On -1, 1. Any one of you, can you tell me? Is it
Again, there is a
uniformly
zero.
continuous?
At
No, no,
0,
madam.
it is not.
Here also 0, madam.
Again, there is a zero interval.
It is not uniformly continuous on minus. As 0 is there in this interval. At this point, this is not continuous. If it is not continuous, it is not uniformly. In that interval, any interval containing discontinuity point, if a function, if any interval is containing that, over that interval, f will not be uniformly continuous. ఏదైనా ఒక ఇంటర్వెల్ లో డిస్కంటిన్యూస్ పాయింట్ ఉంటే ఆ ఇంటర్వెల్ మీద ఇది యూనిఫామ్లీ కంటిన్యూస్ కాదు మనం చెప్పేసేయచ్చు. అట్లీస్ట్ వన్ డిస్కంటిన్యూటీ పాయింట్ ఆ ఇంటర్వెల్ లో ఉంటే we can conclude it is not uniformly continuous. Okay, because this is there. Next, fx equal to 1 by x. అది కంటిన్యూస్ కాకపోతే యూనిఫామ్ కంటిన్యూస్ కాదు. సో is what can you say about 2, 3? Is it uniformly continuous or not?
Yes.
Yes.
Madam.
0 is not there in this interval. So uniformly continuous on this. Because f is continuous on closed interval. Okay. So కొన్నిసార్లు we can escape doing like this. ఇది ఎట్లా వచ్చింది కాన్సెప్ట్ అంటే we have the theorem which I stated. Important result we have seen is f is uniformly continuous implies f is continuous. జాగ్రత్తగా విను. దీన్ని నేను ఉపయోగించుకున్నాను యాక్చువల్గా. f is uniformly continuous. UC means uniformly continuous. f is continuous. ఇది ఏ ఫామ్ లో ఉంది? p implies q లాగా ఉంది. సో మీరు ప్రూవ్ చేశారు. Whenever p implies q is true, then automatically negation q implies negation p will be true. If this is true, then this also will be true. So whenever this statement is true, this statement also will be true. Both are equivalent statements. You have done statements in 10th class. When you form the truth table for this, both will give you the same truth values. Last columns in both of them, the output will be the same. Then we say they are equivalent. మీరు 10th class లో చేశారు ఇది. సో ఇది ప్రూవ్ చేయాలంటే ఇది ట్రూ అయితే ఇది ట్రూ అవుతుంది, ఇది ట్రూ అయితే ఇది ట్రూ. సో యూనిఫామ్ కంటిన్యూస్ negation q. You know, uniform continuity implies continuity. This statement is true. We already know this is uniformly the valid statement. But whenever this statement is true, this also should be true. What is this means? Negation q. Negation q means f is not continuous. Negation means if there is not, introduce. If there is not, remove. F is not continuous implies f is not uniformly continuous. Negation q implies negation. Statement. Not continuous అయితే automatic గా not uniformly continuous. So suppose f is not continuous at some point. If that point is in the interval, we can conclude that f is not uniformly continuous on that interval containing the discontinuity point. ఇక్కడ మీరు ఇంతకు ముందర చూసారు -1 1 లో ఇది 0 ఉంది. సో f is not continuous at 0. So f cannot be uniformly continuous on any interval containing that point. ఇది మనం కంక్లూడ్ చేస్తాం, దీన్ని ఉపయోగించుకున్నాం. సో కొన్నిసార్లు ఇప్పుడు మనం చూడంగానే చెప్పేసేయచ్చు fx = బాక్స్ x ఉంది, అది కంటిన్యూస్ అవుతుందా? కాదు, అట్ ఇంటీజర్స్, దట్ ఈస్ ఇంటర్వెల్ కంటైనింగ్ ద ఇంటీజర్స్. సో మనకి ఇప్పుడు fx = బాక్స్ x ఉంది. ఈస్ దిస్ uniformly continuous on the interval 1, 3? అడిగాను, మీరు ఏం చెప్తారు? వాట్ ఈస్ యువర్ ఆన్సర్?
No.
No.
No. Is fx = box x uniformly continuous? No. ఎందుకు? It should be continuous at every point in this interval, including 1, including 3. అంతే కదా, అది కంటిన్యూస్ అయితేనే యూనిఫామ్లీ కంటిన్యూస్ అవుతుంది. సపోజ్ దీని డిస్కంటిన్యూటీస్ ఇందులో ఒక్కటున్నా కూడా అది యూనిఫామ్లీ కంటిన్యూస్ కాదు. సో ఆన్సర్ ఈస్ నో. Why? Because box x is discontinuous at every integer, at every x belonging to set integer. In this interval, what are the integers? What are the integers?
1, 3.
Antena? Yes.
2 also. 2
1,
also.
2, 1,
fx =
1,
box
2,
x is
3.
discontinuous
1, 2, 3.
1, 2, 3.
at 1, 2, 3. What is this interval means? Including 1, including 3, all the real numbers. Infinitely many are there. Real numbers. In any interval, there will be infinitely many reals. But what are the integers you are having? Only 2 is the only integer. Remaining are also there, but they are not integers. At not integers, it is continuous. Discontinuous only at the integers. So at 1, 2, 3. At all other points, it is continuous. But one failure is failure only. 1, 2, 3 belonging to 1, 3. All of them belong to this. Therefore, f is not continuous on the interval. Because one failure is failure, overall failure. So if it is not continuous, it cannot be uniformly continuous. Not uniformly continuous. Open interval అయితే may be true, may not be true. We don't know. We have to go for original definition. ఓపెన్ ఇంటర్వెల్ ఇస్తే ఎట్లా చెక్ చేస్తారు మరి యూనిఫామ్ కంటిన్యూటీ? క్లోజ్డ్లో అయితే కంటిన్యూస్ అయితే యూనిఫామ్లీ కంటిన్యూస్, యూనిఫామ్లీ కంటిన్యూస్ అయితే కంటిన్యూస్, రెండు వైపులు. కానీ ఇది కనుక ఓపెన్ ఇంటర్వెల్ ఇస్తే ఇట్ మే ఆర్ మే నాట్ బి యూనిఫామ్లీ కంటిన్యూస్. అప్పుడు ఏం చేయాలి? ఒరిజినల్ డెఫినేషన్కి వెళ్ళాలి, ఎప్సిలాన్ డెల్టా. సో ఒక స్టేట్మెంట్, f is continuous on AB if and only f is uniformly continuous. Theorem on this. So if it is continuous, automatically uniformly continuous. If it is uniformly continuous, automatically it is continuous, both the sides. So if f is uniformly continuous on closed interval, it is continuous. If and only if అంటే అర్థం ఏంటి? రెండు వైపులా. If it is continuous on closed interval, then uniformly continuous. If it is uniformly continuous, then it is continuous, both the sides. But if it is open, we cannot. We don't. Then how to do it? We have to go for original definition and check. Okay, I'll show you how to check that also. So from next time onwards, whenever you are given any question, you check whether that function is continuous over the interval. If there is at least one failure in that point in that interval, then we say it is not uniformly continuous. Okay, for example, sin 1 by x. Example, we know it is having discontinuity. It is having discontinuity of which kind? Any one of you, do you remember?
Second kind.
Second kind. At
Kind.
what point? At
Zero.
what point? 0. At all
Second.
other points?
Continuous.
Continuous, happy. If it is continuous, then automatically it is uniformly continuous. అంతేగాని చూడంగానే అట్లా మనం డినై చేయకూడదు. sin 1/x అనగానే నాట్ యూనిఫామ్లీ కంటిన్యూస్ అట్లా అనకూడదు. ఈస్ ఇట్ ఈస్ డిస్కంటిన్యూస్ ఓన్లీ అట్ 0. ఈజ్ 0 present in that interval or not? 0 కనుక ఇంటర్వెల్ లో ఉండకపోతే హ్యాపీలీ ఇట్ ఈస్ కంటిన్యూస్ యాజ్ వెల్ యాజ్ యూనిఫామ్లీ. అంతేగాని చూడంగానే చెప్పేయకూడదు. ఎక్కడ అడుగుతున్నారు అది చూసుకో. ఇంపార్టెంట్. ఇంటర్వెల్ ఈస్ ఇంపార్టెంట్. సెట్ ఈస్ ఇంపార్టెంట్. So therefore, very important point is, that is sin 1/x is continuous on R star. R star means R minus.
R minus G.
ఈ ఇంటర్వెల్ లో హ్యాపీగా కంటిన్యూస్. బట్ ఇట్ ఇస్ డిస్కంటిన్యూస్ ఓన్లీ అట్ 0. 0 is the only problematic point. సో చాలా మంది అట్లా కంక్లూడ్ చేసేస్తారు. అట్లా చేయకూడదు. ఇంటర్వెల్ చూస్తారు. ఈ ఇంటర్వెల్ 0 ఉందా? Therefore, f of x equal to sin 1/x is f of x equal to sin 1/x question uniformly continuous on 0, 1, 2, 3, -2, minus. చెప్పగలుగుతారా? ఏ ఇంటర్వెల్ లో అది యూనిఫామ్లీ కంటిన్యూస్ అవుతుంది?
Second and
Second.
third.
సెకండ్. ఎంచేత? బికాస్ ఇట్ ఈస్ ఓన్లీ
Zero
ప్రాబ్లం
is not there.
హియర్ 0 is included. 0 is included. So we cannot. Here it is not there. 0 is not there. 0 is not. So it is uniformly continuous. Okay. So open interval.
Well, all no.
We have to check. We have to check because there is no theorem. If f is continuous on open interval, if f is continuous on open interval, then f may or may not be uniformly continuous. Very important. అది ఎలా చెక్ చేయాలి? Go to original definition. If it is not continuous, definitely, if it is continuous on closed interval, then uniformly continuous. If it is not continuous on closed interval, then not uniformly continuous. But if it is open, then f may be continuous on the open interval, but it may or may not be uniformly continuous on open interval. You have to test using epsilon and delta definition. You have to find out delta and check whether it is depending only on epsilon or not, as we have done earlier. ఏమో ఐడియా వచ్చిందా? ఏమైనా డౌట్స్ ఉన్నాయి? ఓపెన్ ఇంటర్వెల్ అయితే చెప్పలేమో, ఎప్సిలాన్ డెల్టాకి వెళ్ళాల్సిందే. ఇంతకు ముందర మనం చేసింది. సో ఎనీ డౌట్స్ ఇన్ దిస్? చెప్పండి. ఏమైనా డౌట్స్ ఉంటే చేద్దాం, లేకపోతే నెక్స్ట్ కాన్సెప్ట్కి వెళ్ళిపోదాం.
Okay, ma.
ఓకేనా? సో ఇంకా కొంచెం ఇంట్రెస్టింగ్ రిజల్ట్స్ ఉన్నాయి. You note down when you are preparing notes. That may be helpful for the theoretical question. A uniformly continuous function, every uniformly continuous function, every uniformly continuous function need not be bounded. Every continuous function is bounded, but uniformly continuous function need not be bounded. Need not be bounded means sometimes it may be bounded, sometimes may not be bounded. What is the example? F of x equal to x. It is uniformly continuous everywhere in particular. Why? Because this is continuous everywhere, and you can apply epsilon delta definition and you can see this is uniformly continuous on R. But it is not bounded.
మ్యామ్ ఇది ఒకసారి నేను కూడా ఒక క్వశ్చన్ చూసాను మ్యామ్. ఎఫ్ ఫ్రమ్ క్లోజ్ ఇంటర్వెల్ ఏ కామా బి టెన్స్ టు ఆర్ ఇచ్చి ఈజ్ యూనిఫామ్లీ కంటిన్యూస్ ఆన్ క్లోజ్ ఇంటర్వెల్ ఏ కామా బి అని ఎఫ్ ఈజ్ అన్బౌండెడ్, ఎఫ్ ఈజ్ బౌండెడ్,
అది
ఎఫ్ ఈజ్ నాట్ కంటిన్యూస్
అదే
అలా
ఇది ఇట్లా ఇస్తాడు మీకు, అందుకోసం ఇది చూసుకోవాలి. ఇట్లాంటి క్వశ్చన్స్ వస్తాయి. సో ఎఫ్ ఆఫ్ ఎక్స్ ఈక్వల్ టు ఎక్స్ ఈస్ యూనిఫామ్లీ కంటిన్యూస్ బట్ ఇట్ ఈస్ నాట్ బౌండెడ్. వై ఇట్ ఈస్ నాట్ బౌండెడ్? ఎక్స్, what are the values x takes? X belongs to R. X belongs to R. X is between minus infinity and plus. So it is not neither bounded below nor bounded above. So if it is not bounded below, lower bound exists avakapoyina unbounded. Upper bound exists avakapoyina unbounded. Rendu exist avakapothe inga automatically unbounded. So if it is uniformly continuous function, it may or may not be bounded. అదే కంటిన్యూస్ ఫంక్షన్ అయితే బౌండెడ్, కానీ యూనిఫామ్లీ కంటిన్యూస్ ఫంక్షన్ అయితే మే ఆర్ మే నాట్ బి, ఇట్ ఈస్ ఇన్ దట్ పర్టికులర్ ఇంటర్వెల్ ఇట్ మే నాట్ బి బౌండెడ్. అండ్ another interesting result, a continuous bounded function, a continuous bounded function, it is continuous and bounded, may not be uniformly continuous. అది కంటిన్యూస్ అయ్యి బౌండెడ్ అయితే ఏమన్నా యూనిఫామ్లీ కంటిన్యూస్ అవుతుందంటే చెప్పలేం. క్లోజ్డ్ ఇంటర్వెల్ అయితే చెప్పచ్చు. ఇట్ ఇస్ కంటిన్యూస్ ఆన్ క్లోజ్డ్ ఇంటర్వెల్, దెన్ డెఫినెట్లీ యూ కెన్ సే ఇట్ ఇస్ యూనిఫామ్లీ. అంటే అది ఏదైనా సెట్ అయింది అనుకోండి, ఫర్ ఎగ్జాంపుల్ ఆర్ ఉంది, ఆర్ ఇస్ అన్ ఓపెన్ ఇంటర్వెల్ మైనస్ ఇన్ఫినిటీ ప్లస్ ఇన్ఫినిటీ, అది సెట్ కానీ ఓపెన్ ఇంటర్వెల్ కానీ అయితే కంటిన్యూస్ అయినంత మాత్రంతో యూనిఫామ్ కంటిన్యూస్ అని చెప్పలేము. పోనీ బౌండెడ్ అయింది కంటిన్యూస్ అయింది అప్పుడైనా చెప్పగలమా అంటే నో, చెప్పలేము. సో మనకు ఓన్లీ వన్ రిజల్ట్ ఏంటంటే, ఇఫ్ ఇట్ ఇస్ కంటిన్యూస్ ఆన్ క్లోజ్డ్ ఇంటర్వెల్ ఆటోమేటికలీ యూనిఫామ్లీ కంటిన్యూస్, ఇఫ్ ఇట్ ఇస్ యూనిఫామ్లీ కంటిన్యూస్ ఆటోమేటికలీ ఇట్ ఇస్ కంటిన్యూస్. ఓకే, యూనిఫామ్ కంటిన్యూటీ అనేది కొంచెం రీఫైన్డ్ కాన్సెప్ట్, అంటే హయ్యర్ కాన్సెప్ట్. మీకు డిస్టింక్షన్ వచ్చింది అనుకోండి, ఆటోమేటిక్గా అక్కడ ఫస్ట్ క్లాస్ వచ్చింది, అనుకో మీరు డిస్టింక్షన్ అని చెప్పలేదు. కొంచెం రీఫైన్డ్ కాన్సెప్ట్. యూనిఫామ్ కంటిన్యూస్ అయితే ఆటోమేటిక్గా కంటిన్యూస్, కానీ కంటిన్యూస్ అయినంత మాత్రంతో యూనిఫామ్లీ కంటిన్యూస్ అని చెప్పలేదు. ఎప్పుడు చెప్పగలము? ఇఫ్ ఇట్ ఇస్ కంటిన్యూస్ ఆన్ క్లోజ్డ్ ఇంటర్వెల్, then automatically it is uniformly continuous. Then when is it going to be continuous on the infinite intervals? So let us see that. So we have a concept again, another interesting definition. ఈ డెఫినేషన్ నుంచి కూడా మీకు క్వశ్చన్స్ వస్తున్నాయి, అదొకసారి చూద్దాం. సో when is it said to be uniformly continuous on open interval? ఇప్పటిదాకా మనం క్లోజ్డ్ ఇంటర్వల్ గురించి. So when is it said to be uniformly continuous over open interval? So if f is continuous on open interval, very important one. Continuous on open interval ante at every point in between me, then f is uniformly continuous. Generally uniformly continuous avakkarledu. But when is it going to be uniformly continuous? In general, no. But in particular, if it satisfies two extra conditions, limit x approaching a plus of x, and what is the meaning of this? RHL at a, limit x approaching a plus means RHL at a. And limit x approaching b minus means LHL at b, both exist. If these two exist, then f becomes uniformly continuous on open. So if it is continuous, we cannot say uniformly continuous, but if these two extra conditions are satisfied, at the end point, at this point, right limit should exist. At this point, left limit should exist. If they exist, then we can say it is uniformly continuous. Then when is it said to be uniformly continuous on R? R is minus infinity and plus infinity. మీకు ఇవి ఫైనైట్ అయితే చెప్తాం. సపోజ్ ఇన్ఫినిటీ అయితే then when is it said to be uniformly continuous on R? If a function, if f is continuous on, if f is continuous on R, continuous అయిన మాత్రం తోటి యూనిఫామ్ కంటిన్యూస్ అని చెప్పలేము. And two more conditions. Limit x approaching infinity, fx exists. And limit x approaching minus infinity, fx exists. Both exist. Then f is said to be uniformly continuous. F is said to be uniformly continuous on R. So when is it said to be uniformly continuous on closed interval? We have seen. When is it said to be closed interval on R also we have discussed. So if it, at the end points, fx will be given to you. So how to test whether it is uniformly continuous on R? First test whether it is continuous on R. That means for every point, for example, fx equal to x, everywhere continuous. Fx equal to x square, everywhere continuous. Not only that, if this limit exists and if this limit exists. When do we say it exists? We have seen. F is said to be uniformly continuous on R. So let us do, if you are interested, we will do one question using x1 and x2 on open interval. On open interval, I'll show you one question. So let us see uniform continuity on the open interval. With that, we'll close this concept, enter into differential. But at present, I would like to discuss one question for your concept clarity. So to have concept clarity, let us do one question, for example. So let us do this. If fx is equal to, is the function, I will give you one question. Let us do this. Is the function fx is equal to x by x plus 1 uniformly continuous on closed interval 0 to. If so, find delta. We want to find out what is the value of delta for which this is going to be satisfied. We want to know, is it continuous or not? If so, what is the value of delta? So how do we find out delta? What is the condition? fx1 minus fx2 should be less than epsilon whenever x1 minus x2 is less than delta. Is it uniformly continuous or not means చెప్పగలుగుతారా ఎవరైనా? Yes or no?
No, madam.
Uniformly continuous or not అంటే మీరు ఏం చేయక్కర్లేదు, అది చూడంగానే చెప్పేది. If so, find
Yes, sir.
delta.
Yes, madam.
Yes, sir. Why it is uniformly continuous?
Closed interval 0,2. There is no any point of discontinuity.
At what point it is not defined?
X
A
equal
point
minus
దగ్గర
1.
infinity
Minus
అవుతుంది,
1.
x equal to
Minus
minus 1.
1.
If x equal to minus 1 only, something by 0 is becoming infinity. It is not defined. So f is discontinuous. F is discontinuous. F is continuous everywhere. Continuous everywhere except at x equal to minus. is -1 in this interval.
No.
Which
Not known.
continuous అన్నప్పుడు in particular 0 to 2 మధ్యలో కూడా అది continuous. If it is continuous, then automatically it is uniformly. Okay. Suppose దీన్ని ఓపెన్ ఇంటర్వల్ అడిగారు. Is it continuous? Is it uniformly continuous on open interval? Suppose ఇదంటే ఇది అడిగితే ఇట్లా చెప్తున్నారు, ఎందుకంటే కంటిన్యూస్ ఆన్ క్లోజ్డ్ ఇంటర్వెల్ అయితే మనకి రిజల్ట్ ఉంది యూనిఫామ్లీ కంటిన్యూస్ ఆన్ 0. కానీ ఓపెన్ ఇంటర్వెల్లో చెప్పగలుగుతామా? దీనికి చెప్పాలంటే మనం వీ హ్యావ్ టు గో ఫర్ డెఫినిషన్. ఏ డెఫినిషన్కి వెళ్ళాలి? ఎప్సిలాన్ డెల్టా డెఫినిషన్. సో ఇది ఓపెన్ ఇంటర్వెల్ అయినప్పుడు మనం ఎప్సిలాన్ డెల్టా డెఫినిషన్కి వెళ్ళాలి. ఎలా చేయాలో చూపిస్తాం. So if it is closed, you need not do anything. Happily you can conclude that it is uniformly continuous. So for this, there is no theorem, no standard result. So we have to proceed. How to proceed? Original definition. So given, what is the set that is given to you? 0, 2. What is the meaning? All the real numbers in between 0 and 2. How many real numbers will be there? Infinitely. 0 not included, 2 not. So to check uniform continuity, given epsilon, we have to find delta depending on only epsilon, such that fx1 minus fx2 is less than epsilon whenever x1 minus x2 is less than delta. So what we have to do? We have to solve this inequality. మనకి ఇచ్చింది ఏంటమ్మా? fx equal to x by x plus. మీరు ఇక్కడ x1 x2 బదులు x and y కూడా అనుకోవచ్చు, మీ ఇష్టం. xy అనుకోవచ్చు, x1 x2 అనుకోవచ్చు, anything which you feel as comfortable. So let us take x1 and x2 belonging to SB arbitrary. Because whenever you have to prove for any, you should not fix the value. So when are they going to be in S? Provided they are between 0 and 2. x1 is between 0 and 2. x2 is also between 0. Because we are taking them in S. Remember. Now let us consider fx1 minus fx2. x1 by x1 plus 1, x2 by x2 plus 1. We have to make it less than epsilon. So simplify this. So how to simplify this? You can directly take LCM. x1 x2 minus x1 minus x1 x2 minus x2 divided by x1 plus 1 into x2
Plus x1, ma'am.
plus x1 plus x1. Correct. Good. x1 square plus x. Correct. Good. Which implies x1 minus x2 by modulus x1 plus 1 plus modulus x2 plus 1. So now we have to make it less than epsilon. This should be less than epsilon. This can be rewritten as x1 minus x2 1 by x1 plus 1 1 by x2 plus 1. Okay. Now we have to make it less than epsilon. So x1 minus x2. You can also write it as 1 by mod x1 plus 1. 1 by mod. This is fx1 inside. We want this to be less than epsilon. When is this less than epsilon? Only when this total is less than epsilon. Okay. If this total is less than epsilon, this should be constant. Then only we can proceed. But here we are having x1 and x2. So we have to find a bound for this. How to find? Let us. But constant is called ఎందుకంటే our delta should be independent of x1 and x2. x1, x2 రాకూడదు మన డెల్టాలో. ఇప్పుడు మనం డైరెక్ట్ గా దీన్ని లెస్ దాన్ x1 minus x2 less than. It is in terms of delta. Delta is in terms of epsilon, x1, x2. But we want it to be independent. We don't want x1 and x2 in delta. Then how to do it? So, in order to do that, we need to proceed further. We cannot stop here. We have to get this as limits for this. How to get limits for this? We have x1 is between 0 and 2, which implies x1 plus 1 is between 0 and 2 plus 1, 3. Add 1, which implies modulus x1 plus
1 to 3
is equal to x1 plus 1 is between 1 and 3. That means x1 plus 1 is positive. This implies x1 plus 1 is definitely positive. And mod x1 plus 1 is x1 plus 1. Because whenever the positive number is positive, modulus is itself. And x1 plus 1 is less than 3. And greater than. So we want 1 by x plus 1 value. Reciprocate. When you reciprocate, inequality will get reversed. Inequality will get reversed whenever you reciprocate. We want 1 by 3 less than 1 by x1 plus 1 less than 1. 1 by 1 is 1. Give some number 3. Less than. Similarly, if you proceed, we get same because condition is the same. x2 is also between 1 and 2. Sorry, 0 and 2. So we get less than 1, greater than 1. Because x2 is also between 0 and 2 only. You can see x1 is between 0 and 2. x2 is also between 0 and 2. So whatever result that holds good for x1 equally holds good for x2 also. You need not do. So let us substitute here in this. We want this. Substituting into, we get modulus of fx1 minus fx2 is less than modulus of x1 plus x2 into, sorry, x1 minus x2 into 1 by mod x1 plus 1 into 1 by mod x2 plus 1. Just now we have proved this is less than 1, this is less than. So x1 minus. This is less than 1, this is also less than. Therefore, fx1 minus fx2 is less than x1. This is less than epsilon, whenever this is less than. Therefore, fx1 minus fx2 less than epsilon, whenever x1 minus x2 is less than. LHS is less than epsilon only then, but given x1 minus x2 is less than delta. So when are both going to be satisfied? So x1 minus x2 is less than delta and x1 minus x2 is less than epsilon is possible if and only if delta is greater than 0, less than or equal to epsilon. So how many deltas are there? Infinitely many are there. Epsilon, epsilon by 2, epsilon by 3, epsilon by 10, anything you can take. But all of them are depending only on epsilon. There is no x1, no x2. It is not depending on points. For all x1 and x2, you are getting your delta constant without x1 and x2. Therefore, f is uniformly continuous on. Yes, it is open. So for open interval means we have to go to open.
మ్యామ్
సో విత్ దిస్ చెప్పండి.
మ్యామ్ ఇలా కాకుండా లిమిట్ ఎక్స్టెండ్స్ టు 0+ అండ్ లిమిట్ ఎక్స్టెండ్స్ టు 2- అలా తీసుకుంటే కూడా చేయొచ్చా మేడం
అలా
అలా?
కూడా చేయొచ్చు, 0- తీసుకొని. సో
ఎందుకంటే ఈజీగా ఫైన్ చేయొచ్చు కదా మేడం అలా?
చేయొచ్చు, కానీ ఇక్కడ మనం డెల్టా అడిగాను.
ఓకే.
ఇక్కడ డెల్టా అడిగారని దీనికి వచ్చి
ఒకవేళ యూనిఫామ్ ఎస్ మ్యామ్. అంటే ఫర్ ఎగ్జాంపుల్
చేయొచ్చు.
యూనిఫామ్
ఇప్పుడు చేస్తాం ఇదే చేస్తాం. సో ఇక్కడ మనం ఎందుకు ఎప్సిలాన్ డెల్టాకి వెళ్ళాము అంటే, బికాస్ వీఆర్ ఆస్క్డ్ టు ఫైండ్ వాట్ ఈస్ ద డెల్టా. సో వాట్ ఈస్ డెల్టా? దీస్ ఆర్ ఆల్ ద డెల్టా వాల్యూ. బట్ సపోజ్ వీఆర్ ఆస్క్డ్ టు ఫైండ్ simply x/x+1 is uniformly continuous on 0 to అని అడిగారు. డెల్టా అడగలేదు మేము. అడగకపోతే యూ నీడ్ నాట్ డూ లైక్, యూ కెన్ డైరెక్ట్లీ గో ఫర్ దిస్ మెథడ్. నేను ఇంతకు ముందర నేను చెప్పాను కదా, అదే నాగరాణి చెప్తాను. వెన్ ఈస్ f is said to be uniformly continuous on open interval? ఇప్పుడే మనం చెప్తున్నాం కదా, if and only if first one it should be continuous on open interval. Next one, limit x approaching a minus fx should exist, a plus should exist. Number 3, limit x approaching b minus fx should exist. So already we know it is continuous on this because -1 is not there. So we know f is continuous on open interval. So sufficient to check only 0 exist or not, 2 exist or not. Let us see. So consider limit x approaching 0+. 0+ అంటే అర్థం ఏంటి? గ్రేటర్ దాన్ fx. When x is greater than 0, what is fx? For all the values you are
Greater
given,
than 0.
what is the meaning? For x greater than 0 and less than 2, greater than 0 also function is this only, less than 2 also function is this only. There is no break at all. Let us take this. So fx is, when x is greater than 0, x/x+. Replace x by 0 because there is no break. You are getting unique value or not? Yes. Therefore, it exists. Limit exists. You are getting unique value. If you get unique value, limit exists, which is unique. You are not getting 2 or 3 values. Therefore, this is, we say it. Similarly, we have to find limit x approaching 2-. 2- means less than 2. When it is less than 2, what is the function? Same, x/x+. Replace x by 2. Is it unique or not? You are not getting 3-4 answers, only unique answer. If you get square root, for example, √4 ± 2, not unique. But whereas here it is unique. Or limit exists. So according to that concept, f is uniformly continuous on open. You can use. So epsilon delta అడిగితేనే ఆ మెథడ్. What is the value of delta? Just to tease you or just to know whether you know the concept or not. They may ask you to find delta value. If it is uniformly continuous, what is the value of delta? The examiner only will give you the answer. It is uniformly continuous on open interval 0. What is the value of delta? Delta is. Then you have to do using previous. But if you are asked to only test whether it is continuous or not, and left hand limit, right hand limit at left hand exist or not, and right hand limit at left hand exist or not, at a exist or not, a plus limit x approaching a plus exist or not, b minus exist or not, we have to find. Exist means unique answer. Then automatically it will be uniformly. ఒక ఐడియా వచ్చిందమ్మా మీకు అందరికి? ఎందుకంటే ఈ కాన్సెప్ట్ అసలు చాలా మందికి అసలు క్లారిటీ ఉండదు, చెయ్యరు, వదిలేస్తారు కాలేజెస్లో. సో అందుకు అంత క్లారిటీ లేదు. ఇది కూడా అంత పెద్ద క్లారిటీ అని నేను చెప్పను, ఎందుకంటే టైం మనకి సఫిషియెంట్గా లేదు. మళ్ళీ మీరు సిలబస్ ఎప్పుడైంది అని అంటారు సార్ని. అందుకోసమే నేను కొంచెం ఐమ్ రన్నింగ్, బట్ ఇది చేస్తే ఈ టాపికే కొన్ని రోజులు చేయొచ్చు యూనిఫామ్ కంటిన్యూటీ. సో మీరు కొంచెం మీ ఎంట్రన్స్ పాయింట్ ఆఫ్ వ్యూ ఇది సరిపోతుంది.
మేడం, వెరీ క్లియర్ మేడం, ఎక్సలెంట్.
ఎందుకంటే నాలెడ్జ్కి ఇది ప్లాట్ఫామ్ కాదు, రియల్గా చెప్పాలి. దిస్ ఇస్ నాట్ ద ప్లాట్ఫామ్ ఫర్ గెయినింగ్ నాలెడ్జ్. ఒక టాపిక్లో రీసెర్చ్ చేయడానికే ఒక జన్మ సరిపోదు. నేను పిహెచ్డి హోల్డరు, కొంతమంది పిహెచ్డి హోల్డర్స్. మా సబ్జెక్ట్లోనే మాకు ఎంతో ఒక టాపిక్కి, ఇట్లా అన్ని టాపిక్స్కి ఎంత ఉంటుంది రీసెర్చ్? మనం అంత డెప్త్కి వెళ్ళలేము. ఇది ప్లాట్ఫామ్ కాదు మీకు, అది మీ రీసెర్చ్ ఫీల్డ్. ఇక్కడ ఏంటంటే యూ షుడ్ నో సంథింగ్ అబౌట్ ఎవ్రీథింగ్ అండ్ యూ షుడ్ క్రాస్ దిస్ ఫారెస్ట్. ఒక పెద్ద ఫారెస్ట్ని క్రాస్ చేయాలి, అంతేగాని అరణ్యాన్ని అంతా లైటింగ్ చేస్తామా మనం? ఒక ఫారెస్ట్ క్రాస్ చేయాలంటే ఎవరి వల్ల కాదు. అరణ్యం మొత్తాన్ని దీపం వెలిగించడం ఎవరి వల్ల కాదు. మనం వెళ్ళే తోవలో ఒక చిన్న టార్చ్ పెట్టుకొని మనం వేసే అడుగులో ఒక వెలుతురు ఉంటే చాలు, మనం ఈ ఫారెస్ట్ని క్రాస్ చేస్తాం. ఆ ఎఫర్టే మన టార్చ్ లైట్ ఎఫర్టే ఇది. ఒక చిన్న టార్చ్ లైట్ లాగా చేసుకుంటూ పోతున్నాం, మీకు వే చూపిస్తున్నాం. అంతేగాని ఈ అరణ్యం మొత్తంలో ఎక్కడేముంది అంటే మేము కూడా చెప్పలేదు. ఏదో మేము అది ఆల్రెడీ సక్సెస్ అయ్యాం కనుక ఈ మార్గంలో ఎట్లా వెళ్తే ఆ అరణ్యంలో ఒక గైడ్ ఉంటారు చూసారా, ఆ గైడ్ లాగా మేము హెల్ప్ చేస్తున్నాం అంతే. మేము క్రాస్ చేసాం కనుక మీకు ఒక తోవ చూపిస్తున్నాం. అంటే ఇది ఒక తోవే కాదు, మొత్తం ఏముంది అంటే ఎవరని చెప్పాలి. సో జస్ట్ వీఆర్ ట్రైంగ్. ఓకే, అందుకోసం ఈ చిన్నది మీకు చాలు, ఈ ఎఫర్ట్ టు మేక్ యూ టు ఆన్సర్ ద క్వశ్చన్స్. సో రేపు మనం డిఫరెన్షియబిలిటీ అనే కాన్సెప్ట్కి వెళ్ళిపోదాం. అందులో మనకి మళ్ళీ మంచి మంచి క్వశ్చన్స్ వస్తాయి. ఇవాళ కొన్ని చేయలేదు ఎందుకంటే డిఫరెన్షియబిలిటీ ఇది రేపు చేద్దాము. అండ్ విల్ ట్రై టు డూ దట్ ఈస్ మీన్ వాల్యూ థియరమ్స్. ఓకే, థ్యాంక్ యూ సో మచ్.
థ్యాంక్ యూ మేడం, థ్యాంక్ యూ.
Thank you, ma'am.
థ్యాంక్ యూ మ్యామ్.
థ్యాంక్ యూ.
ఇది చాలా యూస్ఫుల్ అమ్మా. మీరు ఇది కనుక నేర్చుకుంటే రేపు చాలా మంది డైలమాలో ఉంటారు. మీరు కనుక బీయింగ్ ఏ టీచర్స్ పిల్లలకు ఈ రకంగా చెప్పినప్పుడు ఖచ్చితంగా వాళ్ళు సాటిస్ఫై అవుతారు. మేడం మీకు చిన్న క్లారిఫికేషన్ మేడం.
సార్ చెప్పండి.
ఇక్కడ మీరు లెఫ్ట్ హ్యాండ్ లిమిట్, రైట్ హ్యాండ్ లిమిట్ 0 దగ్గర 0 + 2 మైనస్ చేసినప్పుడు అది కంటిన్యూస్ కావాలా, ఎగ్జిస్ట్ అయితే సరిపోతుందా?
ఎగ్జిస్ట్ అయితే సరిపోతుంది.
ఇక్కడ కంటిన్యూస్ కూడా అవుతుంది కదా మేడం ఇది ఫంక్షన్?
అది కంటిన్యూస్ కూడా అవుతుంది కానీ అవసరం లేదు, ఎందుకంటే ఆటోమేటిక్గా అది కంటిన్యూస్ అవుతుంది. లిమిట్ ఎగ్జిస్ట్ అయితే లెఫ్ట్ హ్యాండ్ దగ్గర ఎందుకంటే ఫంక్షన్ ఈజ్ యూనిక్లీ డిఫైన్డ్. అందుకోసమని అది లిమిట్ ఎగ్జిస్ట్ అయితే ఆటోమేటిక్గా కంటిన్యూస్ అయిపోతుంది. అందుకోసమని మనం టెస్ట్ చేయాలి.
ఓకే, ఇంకో క్వశ్చన్ మేడం. ఇక్కడ ఫర్ ఎగ్జాంపుల్ మీరు ఇచ్చినటువంటి బ్యూటిఫుల్ ఎగ్జాంపుల్ లో x² ఒకటి ఇచ్చారు, x ఇచ్చారు. చాలా మంది ఇక్కడే కన్ఫ్యూజ్ అవుతుంటారు. వాళ్ళు ఇమాజిన్ చేస్తారు x² ఇస్ ఎ ఫంక్షన్ అనగానే ఇట్ లైక్ ఏ పారాబోలా సిమెట్రిక్ అబౌట్ యాక్సిస్. ఎక్కడ కూడా బ్రేక్ ఉండదు కాబట్టి ఇది కంటిన్యూస్ ఎవ్రీవేర్. కంటిన్యూస్ ఎవ్రీవేర్ అయినంత మాత్రాన అది యూనిఫామ్లీ కంటిన్యూస్ కావచ్చా, కాకూడదా?
అవసరం లేదు, డిపెండింగ్ ఆన్ ద ఇంటర్వెల్. అది క్లోజ్డ్ ఇంటర్వెల్ డిపెండ్స్
మైనస్ ఇన్ఫినిటీ మనము కంటిన్యూస్ ఎవ్రీవేర్ ఇన్ ద సెన్స్ ఇట్ ఈస్ ఎన్ రియల్ లైన్
on the real line, but
Okay.
for testing for continuity, if it is on closed interval, then definitely we can conclude that it is uniformly continuous. But if it is on open interval, we will have to test using our epsilon delta method or sometimes the previous.
Okay. In case
Test.
bounded is also a function is continuous everywhere and bounded అయితే మాత్రం uniformly మేడం?
No,
అది కూడా మే నాట్ బి అంటే
అది కూడా కాదు. కంటిన్యూస్ అండ్ బౌండెడ్ అయితే యూనిఫామ్లీ కంటిన్యూస్ కానవసరం లేదు.
ఇప్పుడు fx = x² మైనస్ ఇన్ఫినిటీ టు ఇన్ఫినిటీ అంటే మైనస్ ఇన్ఫినిటీ
Continuous.
ఇన్ఫినిటీ
కంటిన్యూస్ బట్ నాట్ బౌండెడ్.
థ్యాంక్ యూ మేడం, మంచి ఇన్ఫర్మేటివ్ సెషన్ మేడం. చాలా ఊళ్ళు కూడా ప్రతి ఒక్కరు కూడా బాగా కాన్సన్ట్రేట్ చేసి విన్నారు. ఇందులోకి వెళ్ళి ఇంకా క్వశ్చన్స్ ఫ్రేమ్ చేసి మీకు ఇస్తానండి. ఇంతకుముందు అడిగిన వాటిల్లో యూనిఫామ్లీ కంటిన్యూటీ మీద మీరు ఎక్సలెంట్ గా చేయగలుగుతారు ఏ ప్రాబ్లం ఇచ్చినా కూడా. ఓకేనా సుధారాణి గారు, అంతా ఓకేనా? ఇంకేమైనా డౌట్స్?
ఓకేనమ్మా, shall I leave?
చాలా సేపటి నుంచి 7:30 నుంచి కంటిన్యూస్ గా వింటా ఉన్నారు. వెరీ గుడ్. భాగ్యం మా కాలేజీ పోయొచ్చి కూడా కంటిన్యూస్ గా వింటుంది. నైస్.